Hello, my name is Matthew Krupsak. I am the founder of Theta Informatics LLC and creator of the OpenAthena software. Today I'm very excited to be sharing with you the latest release of our software, OpenAthena for Android, version 0.21. This is the first beta release of OpenAthena for Android and contains a whole bunch of new features, which I'm excited to talk about. This has been in progress for a while now, and really contains some key improvements that enhance the usability of the app and increase its utility. So in previous versions of OpenAthena for Android, if you wanted to calculate locations from a drone image, you had to load a digital elevation model file first of the surrounding area. This was really frustrating as you had to go and obtain this file manually, download it, load it onto your phone, etc. With v0.21, what we've done is we've automated that entire process. So it uses a service called OpenTopography and uses their API to download elevation data automatically as soon as you load a drone image. So it makes it super, super simple to operate. All you have to do is export a drone image from, say, your DJI or Skydio, Parrot, Autel drone, load it in the app, and then you're off to the races, and you can start getting some good location calculations very quickly. This is all powered by the app's internal terrain-raycast simulation geodesy engine that we developed in-house. And it contains our novel technique for remote sensing. So this is useful for just about any application of drones you could think of where accuracy and timeliness of location information is key, such as search and rescue, public safety, law enforcement, land management, agriculture, or defense applications. Really, it has a lot of different use cases. It's really what this technique does is it unlocks the full potential of the sensors that are already there within drones, and really gives them some new capabilities with this metadata processing and sensor fusion technique. So anytime I tap on the screen within an image for any given pixel, it's able to calculate an angle and a starting point of a line, of a ray, and then it simulates that ray until it intersects with terrain as represented by a digital elevation model. This comes from a data set published by NASA and the NGA called the SRTM, Shuttle Radar Topography Mission. It's a super high quality, accurate, and high resolution data set that is public and free to use. So it's really ideal for this kind of application because it can enhance the capability of drones with the sensors they already have. So now I'm going to load, that was an image from a DJI Mavic 2 Zoom. I'm going to load one from a Skydio 2. And then just as before, it'll ask if I want to download an elevation model if I don't have one already. And then it will take a second to load. It downloads of an area of about 15 kilometers on either side. And so even if you travel a little bit, you'll still be covered. If you already have an elevation model downloaded, it'll load it automatically once you load the drone image. If not, it will ask you if you want to download one. And we can see here that, say I traveled by plane, went off to an entirely new place. I don't have to worry about fetching an elevation model beforehand. The app will take care of it. If I'm going to be offline without internet access, what is nice about this version of the app, though, is it will automatically select an elevation model for you if you already had one on your device. So we can see it saved the elevation model I had downloaded earlier for this image. When I loaded this image, it reloaded that elevation model automatically. So now I don't even have to think about it. I can just go back in and start getting some location calculations. Now, say that I need to use this entire software entirely offline. Something that we also support is actually loading in files manually so that they can later be used once you start getting drone images. So we support either downloading from a manually selected area and size, or if you already have elevation model files, it can import them from your device. So it supports either the GeoTIFF or DTED level 2 or higher formats, which makes it super flexible and will be compatible with most of the elevation data that's out there. So I can just see I imported 2 files. If I go into the management interface and go to the list again, I can click on any one of these entries and obtain details such as the boundaries, the time the file was created, the coverage area, center, size of the file, and then I can very quickly share it to any of my team members with the share button, or I can save it to my device so that I can later do whatever with it, which is very convenient. Also new in v0.21 is we added an indicator for the predicted circular error category for the calculation of a target. So the principle that this software uses really depends on the accuracy of the elevation model that it's casting against. The shuttle radar topography mission studies have shown has about 5.9 meters of vertical accuracy. So basically, for estimating the maximum possible circular error around the calculated target that it actually lies within, we basically take that angle downward from the horizon, and we use that with the vertical error to calculate the expected horizontal error. It's a simple trig function. But so what that means in practice is that calculations that are very close to parallel with the ground are going to have a little bit more circular error, while it's like angles that are closer to straight down are going to have a lot less circular error. So we actually quantify that and categorize that now within the app, so the operator can be aware of what kind of location calculation accuracy they're looking at. That being said, if you're in a use case such as like search and rescue, we're very conservative with this estimate, where we estimate on the very, very high end of maximum possible error. If you have like a category 2 or a category 3 calculation from OpenAthena, it's most likely going to be a lot more accurate than that. So still very useful for actually getting timely and accurate location intelligence for some of those critical applications. Yeah. As always, we support output in various different forms. We added the UTM output format for the software in the latest release. And we also revised the cursor on target naming convention. So the app supports cursor on target output to ATAC. Anytime you hit the envelope button, it sends a cursor on target point to all the users connected on the same network as your device. We revised the naming scheme so it's a little bit easier to read and disambiguate. In the middle part, instead of just random letters and characters, it'll be a automatically generated call sign for your individual device. So on this Android phone that I'm recording from, its call sign in the middle here is always going to be Yankee 82. And then it is followed by a serial number for the target calculation. So the last message I sent was Yankee 82.4. Now it's Yankee 82.5. So that makes it a lot easier to operate and use with a team, so you can get that context of the information over to them as well very quickly. Also, we increased the maximum zoom level and added some fine crosshairs which appear when you start to zoom in more. There's also the full screen selection activity if you want a little bit more visual area. We improved the calculation speed for the terrain-raycast itself, so that's more responsive for tapping. We added a user interface that lets you manage the Open Topography API key, which is what is used to actually download elevation models. If you get the app of Google Play, it's going to have one already loaded and ready to go. If you download the app from GitHub or F-Droid, you're going to need to go to the Open Topography website to obtain an API key to load into the app. Also new in this version, The database we have for the drone camera intrinsic parameters is now user configurable. So as new drone models are released, instead of needing to update the app to get support for new drone models, you can just load this drone models.json file that Theta Informatics publishes. So this is really convenient because it means that we can get compatibility to people faster as new drone models come out and are calibrated with our app and the process that we've published. So yeah, that's about all for OpenAthena for Android v0.21. This is the first beta release of the software. I'm super excited to be getting this out there. We've noticed a remarkable improvement in usability with this automation feature, and we're really excited to see what folks can do with it. I've talked to folks from all kinds of different industries and different kind of use cases that they've told me that I hadn't even considered. And we're just really excited to see all of that. We think this is an exciting new capability with drone technology and are really interested to see where you can take it. All of this software is available free and open source at openathena.com. Our support email is support@theta.limited. That's support at theta.limitted. And we're really interested to hear how your experience goes and what you think of the app. So with all that, thank you for watching. I will see you in the next one. Bye.